Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is a procedural programming module. In the last class we have discussed about chapter number 18, that is graphics under Windows, some parts of the chapter number 18 and some practical approach of chapter number 18. Now today I am going to continue with your same chapter, that is chapter number 18, that is graphics under Windows. So first of all, let's take a quick review what we have covered in the last class, then moves to the today's session, that is the Hello Windows and the programming of the Windows, that is how we can apply the graphics in the Windows. So let's take a quick review what we have covered in the last class. In the last class we have covered the topic that is graphics as of now. That is, as of now we are using the graphics with only 16 colors, that is 640 by 480 resolution. That means that the resolution of the graphics that is using is only 640 by 480 resolution, and there are only 16 colors. But in today's world we are going beyond the 16 color, that is the 64 color at least. So that can be achieved by using the 1024 into 768 resolution. That offers almost 16.7 million colors. That is only 16 colors, but this is 16.7 million colors. So in today's world we are using the graphical menus, icons. That means every part of the Windows is GUI, that is a graphical user interface. Everything is based on the graphics. Then we have studied about the graphics or device independent drawing, that is how to use the device independent drawing that uses or that works on a VGA, that is a video graphics array, and modification of this is the SVGA or XGA. So these are the latest version of the VGA. Either we are using the SVGA or XGA. And this says the key to this device independence is the Windows. That is the key that is used for the device independence is a window that is using the device context. So device context is nothing but how we are interfering or how we are using the programs with the help of the graph that is provided by the device context. This says during the original design of the Windows, one of the goal is to provide the device independence. So device independence is one of the goal that is provided by the Windows. That means that the same program should be able to work under different screens. That is, device independent means that is the graphics is not depend on the devices, but they are independent of the devices, so that the same program, if I am using one program, that can work on the different screen, printers, keyboard without modification to the program. So if you have ever had to update the code of a MS-DOS program for the latest printer, plotter, video display or the keyboard, you will recognize device independence as a huge advantage for the developer. In the next paragraph it is saying that Windows program do not send data directly to the screen or printer. That is, Windows program do not send, Windows programs do not directly send the data, but it uses a device that is known as the device context. That means that becomes a mediator for sending the data to the device. This is because Windows uses a standard and consistent way to send the output to the printer or the screen. This standard way is known as the device context. As I told you, the standard way for designing the or for using the printer screen, that is known as the device context or simply a DC. Different DCs are associated with different devices. For example, a screen DC is associated with screen. So for every item or for every program or for every device, there is a device context. For example, for a screen there is a screen DC, and for a keyboard there is a keyboard DC, mouse DC. So anything that is interfering with the graphics, that is associated or that is linked with the DC. The only thing that changed from drawing to screen and the drawing to printer is the DC that is used. So everything is the same, but the different technique is using, that is the DC. In the next paragraph, it is saying that a window program also obtains a handle, that is a ID value for the screen or the printer DC. Now, in mind, what is the advantage of DC? The main advantage of using the DC is that the graphics and the text commands that we send using the DC are always the same. That is the, for example, if I'm using one DC, that has the same commands that we are using, so that we send, so that is the DC that sends same commands regardless of where the physical output is showing up. So it shows the always the same DC that we shows regardless of the things that is happening in the programs. The part of the Windows that converts the Windows graphic functions to the actual commands into the hardware is the GDI. So GDI is a program that is also known as the GDI32, stored in the Windows system directory, that is used for the graphics functions for sending the commands. Windows environment loads GDI into the memory when it is needed for graphical output. So whenever I need a graphics output, that is loaded or that is using or that is converted by using the graphical output. It also says that GDI32 is used or is not a part of the any hardware conversion, but it's a device that is used for storing the data into the memory whenever there is a need for the graphical output. So whenever there is a need for the graphical output, that is done or that is used by using the GDI32, that is used for the video screens and the HP laser printer. Devices are just a program that assists the GDI in converting the graphics into the hardware commands. So drivers are used, for example, printer driver. That is just a program that assists the GDI. GDI is a device, so it can be supported by the drivers that converts the window graphic command to the hardware command. So whatever the command that is using, that is a graphic command, that is converted into the hardware commands by using the drivers along with the GDI. Therefore, GDI provides the basic drawing functionality for the Windows. So every basic functionality of the Windows, that is provided by the GDI. The device context represents a device providing the layer of abstraction, and GDI is like or provides the insolution by calling the appropriate device driver in response to the Windows graphics function calls. Now next part is Hello Windows, that is how to use the Windows, that is simply displaying the content that is a Hello Windows on the screen. So this says we would begin our test with graphics programming under Windows by displaying a message that is the Hello Windows in different fonts. That is in simple terms, this is a program that shows how to display a word or a message or a text that is Hello Windows in different fonts by using the different styles, different text, even using the graphical output in the Windows. So first take a look at the program given below before we set out to understand it. So this is a program that is used for the displaying the Hello Windows in different fonts, in different styles. So this is, first one is hash includes window.h and hash include helper.h. So there are two header files that is used, one is windows.h and one is helper.h. And there are two functions that is calling or that is used. One function name is void on paint and one is void on destroy. So first of all, two header files, one is window.h that contains some library functions, as well as the other one is hash includes helper.h that also includes some library functions. And there are two functions that is using, that is void on paint and void on destroy. Then in bracket there are arguments, that is HNWD, and there is another argument that is also HNWD. Then there is a function or the main function that is a winmain, that is int _std call winmain. So winmain is a function that is like an entry gate in the Windows programming. And there are various arguments. One is h instance, h instance, h instance, h previous instance, lpstr, lpsc, cmd line, int, and cmd show, that is of integer value, that is contains some discrete values. Then there is a curly brace, that means starting of the main function, starting of the Windows main. There is an argument, there is a keyword that is known as ms, and there is a variable that is known as m. So m is a variable of the keyword, that is a msc. Then there is a comment, there is a commenting, or there is a comment that is only for the user friendliness, that is perform application initialization. So in this it is performing the application initialization. So it is a function that is used, that is the first function, that is a init instance. So init instance is the first function that is used, and there are various arguments like h instance, ncmd show, text. H instance is one of the argument, this is of integer type, and this is the text that is used. Then this is the main message loop. So this is the main message loop that is used. In this there is a while get message ampersand m null 0 0. So this is used, that is a get message is a function that is used, and there is a ampersand m, there is a null, and there is a 0 0. So these are the various argument that is used in this. Then there is a dispatch message, this is also a function. This is also a function that contains one argument, that is a ampersand m. Then there is a return 0. So this says while get message, that means while this contains these arguments, or this contains the message, this is used for simply storing the message, and this is used for displaying the message. There is a return 0. The next one is lresult callback Windows procedure, that is also used for the showing the result, that is the lresult callback. Then there is a window proc, then there are various argument that is used. Then there is a switch case that is used, that is a switch message, and then there is a cases, that is a wm destroy, on destroy, hwnd break, case wm paint, on paint, hwnd break, default, windows proc, windows main proc, and there are various argument that is used, that is hwnd message, wparam, iparam. Then there is a curly brace, that is the closing curly brace. So this is the switch case. It means this is the message, that is the first part. There are various parts, that is either using the Windows wm destroy. So if it is the case of the wm destroy, then simply call the function, that is the on destroy function that is calling, and there is a hwnd. This is the argument that is used, and there is a break, that means moves to the next case, that is a wm paint. Then there is a next function, that is a on paint, and there is an argument, that is a hwnd. Then again there is a break. Then last one is your default. It means if it is not of destroy, it is not of paint, then it is using the default part, that is a return def window proc. There are various arguments, that is a hwnd message, wparam, iparam. Then there is a switch case that is closed, and then there is a next part, that is a return 0. Now this is the next part, that is a void on destroy function. So I'm just coming within a 5 minutes, so take 5 minutes break, and then starting or continuing with this function, that is a on destroy. So let's take a break for 5 minutes only. So let's start with the session again. So this is the switch case that is using, that is a switch message. There is a different cases. One is wm destroy. That is, if it is a case of the destroy, that means simply destroy the program of the Windows program. That is then there is a function call, that is a on destroy, and there is an argument, that is a hwnd. And otherwise, if it is not a destroy case, Then another case is of paint. That means displaying the window or displaying the output on the screen, that is done by this function, that is a onPaint HWND. And if it is not of case of destroy, not of the case of the paint, then the default case is simply returns the window procedure, that is a default window procedure, by using these arguments, that is HWND, message, WParam, IParam. Then this is the closing of the switch case. That means this is the part of the switch case. There is a return 0. Why I am using return 0? Because this is the function that is starting with the int. So whenever a function starts with the int, it is good, or it is better to use the return 0 in place of this one. Then this is the definition of this onDestroy function. So this is onDestroy, this is the definition, this is the return type. What is the return type of the function? That is void. That means this function returns nothing, that is of void. Then there is a argument, there are various arguments that is used. There are various arguments that is used, that is a void onDestroy HWND HWND. So this is one of the argument. Then this is the post quit message. So this is the destroy case. If there is a destroy case, then there is a post quit message that is used, that is a post quit message, that is a 0, that contains 0, right? Then another part is void onPaint. This is the next part, this is the next function. If it is not of the case of the destroy, it is a case of the paint. That means this simply displaying on the screen. There are various arguments. This is HWND HWND. There are argument that is used. One is HDC. So this is the keyword that is used, and the variable that is also using the HDC. And then there is a next keyword, that is a paint struct. So this is the struct that is using, that is of paint type for printing purpose, and the variable that is used in the PS. So PS is the variable of the paint struct. Then there is a H font and there is a H font. So this is the font of the message that is denoted by the variable, that is a H font. Then there is a log font, that is also a keyword, and the variable name is F, that contains only 0 value. Then there is a HG and DIOBJ, that is a, and the hold font. So that is the next font, or that is the next variable that is used, that is a hold font. Then there is a next variable that is of fonts, that is of array type, that is of pointer variable. So this fonts is of pointer variable, that is of character type. That means this is an array pointer, that is a string, because it is of character type. And the variables or the values that is using is the Arial, Times New Roman, Comic Sans, MS. So these are the various fonts that is using. In this there is a blank array. That means we can store anything in this array. That is we can store n number of argument in this. The few examples of this font is Arial, Times New Roman, Comic Sans, MS. Then there is a next variable that is declared, that is a int I. So int I is the next variable that is also declared. Then there is a HDC, then begin paint. This is the next part. Then HWND %PS. So this %PS is the address variable that is using, and HWND is the again the argument that is used in this one. So this is the begin paint, means starting with the displaying on the screen, and the output of this function is stored in the HDC. So this HDC is the variable that is storing the output of the begin paint function output. So this is the HDC, that is of HDC type. Now using the for loop. So this is the for loop that starts with the I 0. There is a I that is also declared, that is of integer type. So it starts with the 0, that is I equals to 0, I is less than 3. So it's work for 0, 1, 2. It works for 3, or it works for 3 iterations, that is for 0, and that is for 1, and that is for 2. So it works for 3 iterations, 0, 1, 2, and then there is a I++, that means incrementing the I at every interval, at every looping. It starts with 0, then 1, then 2. Then there is a strcpy. So this is the string copy that is used or that is done, that is the strcpy. And then there are two parts. One is flf face name and then fonts. That means copy the font name that is stored in the font 0. So that means font 0. In f0 there is a variable or there is a value that is a Arial. Why? Because it is the fonts. This is at the 0 location, 1 location, 2 location. Agree? So these are the three values, and I'm using the three looping, that is 0, 1, 2. So at the 0 location there is a Arial, at the 1 location there is a Times New Roman, at the second location there is a Comic Sans MS. These are the names of the font, nothing else. So this strcpy is nothing but it is used for the copying the font of from this to this one. That means at the 0th location, because it start with the 0, at the 0th location there is a Arial. So Arial, that is a message or that is a text that is Arial, that is converted or that is going into this one, that is the f.lf face name. So it copy the content of this destination, this source to this destination. So Arial will be transferred into the face name, that is Arial is stored in the face name, that is a face name equals to Arial. Right, so it is saying in this one also, that is copying the font name. It is stored in this one, that is copying the font name. Then there is a height. This is the font height, that is showing what is the height of the font. That is what is the height means what is the height of the text that is displayed in the font. For example, if I am writing hello, what is the size of the H? What is the size of the E? What is the size of the L? That means height of the font. So it is using f.lf height, then that is equals to the 40, that is multiplied by I plus 1. That is 40 is the size measurement and I, that is the 0 plus 1. That means it is incremented at every location. Then f.lf italic, that means f.lf, that is the italic, that is equals to the 1. Then there is a h font, that is stored as a create font indirect, there is a ampersand f. Then hold font, select object, then hdc h font. That means h font is the variable that is used that stores the output of this function. What is the name of the function? That is a create font indirect. Then there is a hold font, that is also a variable that stores the output of the function, that is a select object. So one is the create font indirect, one is a select object. These are the functions and these are the arguments of this function. One is one argument of this function is ampersand f. So this is the argument that is used. Another one is select object. These are the arguments of the select object. One is hdc, one is the h font. So this is the h font, this is the hold font that is used. Then there is a set text color. So this is the set text color is also the function that is using, that contains the arguments as the hdc. There is a RGB, that is a red, green, blue, and these are the various arguments in this. That is RGB at the red, there is a 0, 0 to 55. So these are the dimensions of the color scheme that is using, and this is the text, set text color. This is the function that is using. Then there is a text out. So this is again the next function that is using. These are the arguments. One is the hdc, then 10, 70 into I, then hello windows. That means what is the text to be displayed as the output, that is the hello windows. Then there is a next function that is also calling, that is the hdc hold font, delete object, h font. So this is the this whole parts execute for the 3 times, that is for the 0th location, for the 1 location, for the 2nd location. Then there is an end pin, that means ending of the displaying or display ending, that is also storing the 2 argument, that is hwnd and the ampersand ps. and this is the closing of this one. This says on execution of this program, the window shown in figure 18.1. This is for the aerial, this hello windows for the aerial, this hello windows for the Times New Roman, and this hello windows for the Comic Sans MS. So these are the three fonts that is showing the output on the screen. So these are the three parts of the windows. This says drawing to a window involves handling the WM Paint message. This message is generated whenever the client area of the window needs to be redrawn. So this says drawing to a window involves WM Paint. So this is the WM Paint that is using, or that is we are using, that is a WM Paint. This is we are using for displaying, for handling the message. This message is generated whenever the client area of the window needs to be redrawn. So whenever I want to redraw the client area of the window, or the window again to be redrawn, that is done by the, or then that is used by using the WM Paint. This redrawing would be required in the following situations. So whenever we want to redraw the message, that can be provided, or that redrawn will be required in the following scenarios, for following situations. What are the situations in which we are using the WM Paint? That is, what are the scenarios in which we are using the WM Paint? Whenever, the first point is when the window is displayed for the first time. So it is using, or it is used, WM Paint is used whenever we use the window for the first time. So if there is a first program of my system, then it is using the WM Paint. Another condition is that when the window is minimized and then maximized. So first of all, when the window is maximized and then it is minimized, then also it is using the WM Paint. Third condition says when some portion of the window is overlapped by another window. Suppose there is a some portion of the window that is overlapped by another window. In that case also there is a WM Paint, there is a next part, or there is a WM Paint function that is calling, or that is executed. Another condition is that, another situation is that when the size of the window changes on stretching its boundaries. So these are the various conditions in which we are using the WM Paint message. So first point says when the window is displayed for the first time, when the window is minimized, maximized, when some portion is overlapped by another window, when the size of the window changes on a stretching its boundaries, when the window is dragged out of the screen and then brought back into the screen. So that means when the window is dragged out of the screen, whenever we drag out of the screen and then again back into the screen, that is also the condition in which we are using the WM Paint. Next paragraph says, would a WM Paint message be generated when the cursor is dragged in the window? So whenever we drag the cursor, this is the message that is generated. In this case, the window saves the area that is overlapped by the cursor. Suppose we drag the window, so there is a overlapping of the cursor, there is overlapping of the window. So that overlapping will be saved, or that saves the area of the overlapping, that is done by the WM Paint. And then again restore it when the cursor moves to the next position. Suppose I pinpoint on the title bar, then I drag it to the next location. That means using the cursor, I drag to the next location. That is also covered, or that is also done by the WM Paint. So in this case, we are using the WM Paint because that saves the area. Next point says, when the switch case structure inside window procedure function finds the message ID passed to the window proc is WM Paint. That is, when the switch case is used, or when the switch case structure is used inside the window procedure that finds the message ID that is passed to the window proc, that is the window procedure, that is a WM Paint function. So this WM Paint function is used for the window procedure. It calls the function that is the onPaint function. So onPaint function is the name of the function that is used within the Windows procedure. Within onPaint, we have called the API function that is the begin paint. So whenever we use the onPaint function, we have called, or we have to use the another API function, that is the application programming interface function, that is known as the begin paint. So begin paint is also another function that is using. This function obtains a handle to the device context. So begin paint is another function that is also used, or that is also handled by the DC, that is a device context. Additionally, it also fills the paint structure with bulletin or with information about the area of the window that which needs to be repainted. So we are also using the next, or the paint struct, that is a structure that also contains the area of the window which needs to be reprinted. Lastly, it removes a WM paint from the message queue. So at the end, there is a remove of the, or the destroy of the WM paint function from the queue. After obtaining the device context module, the control also enters a loop. So after obtaining this one, the control enters a loop. Inside the loop, we have displayed hello windows in 3 different fonts. So this paragraph shows the explanation of the switch case. That means this is the program, this is the program. So till this point, this is the explanation that we have covered. Now this is the explanation of this for loop, that is the next paragraph. Inside the loop, that is the for loop, we have displayed hello windows in 3 different fonts, that is Arial, Times New Roman, and the Comic Sans MS. Each time through the loop, we have set up a log font structure, that is a F. We are using the log font structure, that is a F, that is initialized with the 0, with this one. This is the log font, that is the F equals to 0. Right. This structure is used to indicate the font properties like font name. So this structure, that is a log font structure, is used to define the, or to indicate the font properties. What are the font properties? Like font name, that is Arial, font size, that is the font height, that is 24, 23, 16, italic, normal. Italic means there is some slant of the hello, then there is a normal, that means there is no slant, etc. Note that in addition to these, there are other font properties. That means log font also contains other properties of the font that may be set up. The property that we have not set up in the loop are all initialized to 0. So that is the properties that we have not set up in the loop are the properties that is initialized to the 0. So once the font properties have been set up, we have called the create font indirect function. So this is the next function that is using, that is calling up, that is a create font indirect. So this is a function that have been set up after, or that have been used after setting up the font properties. Then we have called the function that is a create font indirect. So this is the next function that is using, that is the next API function, that is a create font indirect function to create the font. This function loads the relevant font file. So with this function, that is the create font indirect function, this is the API function that loads the relevant font file that is using. Then using the information is in the font file and the font property set up in the log font structure, it creates a font in the memory. So after using the information from the font file and the font properties set up in the log font structure, then it creates a font in the memory. Then next part is create font indirect returns the handle to the font created in the memory. So this is the next function that is using, that also returns the handle to the font that is created in the memory. This handle is then passed to the select object. So one is create font indirect, one is the select object, that is the selecting the object, that is also the another API function to get the font into the DC. So whenever we have to select the object, we are using the select object, and we have to get the font into the device context, that is a DC. This function means select object function returns the handle to the existing font in the DC. So it returns the handle, how to handle the existing font in the DC, which is preserved in the hold font variable. Next we have used the set color or set text color API function to set the color of the text to be displayed. Next function that we are using, that we have used, the set text color API function to set the color of the text to be displayed with the text out. So text out is the next function that is used to set out the color of the text. For example, I have displayed the graphics, then we have used the text out function to display the text in the proper color. The RGB macro that uses the red, green, blue. So this RGB function uses the three colors, that is the red, green and the blue color, each component having the 32-bit color value. So every red color also uses the 32-bit, green also uses 32-bit, blue also uses 32-bit color. And that each color component, that is either red, blue or green, every component have a value that ranges from 0 to the 255. To text out, this is a text out, that is the next function. We have to pass the handle to the DC. So with the using of text out function, we have passed the handle, we have passed the scenario, we have passed the output to the DC, that is the device context position, where the text is to be displayed. The text is to be displayed and its length. Next, with H font, that is a H font, also we are using only one font can be associated at a time. That is, whenever we use the H font, there is only one font that is associated with the at a time, that is using the H font. Hence, before associating another font with it, we have to delete the existing font using the delete object. So with the font H font, we are associated with only one font at a time, but hence before associating another font, that is before using the another font with it, we have to delete the existing font. So whenever we have to use another font, so we have to first of all delete the existing font using the delete object function, that is the API function. Once outside the loop, we have used the end paint function. So this is the last part that is the outside the loop, we are using the end paint function. API function, this is also API function to release the DC handle. So first of all, it is using the H font, that is used for only one font that is using. Then use the delete object function to delete the existing font. Then uses the end paint, that means to release the DC handle, we are using the end paint function. If not released, we would be wasting precious memory. So if this is the function, that is, if the DC or device context does not release the memory, does not release the end paint function from the memory, so it wastes the memory. So it wastes the memory because the device context structure would remain in memory, but we would not be able to access it. In place of text out function, we can also use the .text function. So in place of the text out function, that is, instead of using the text out function, we can use the .text function, .text API function. This function permits finer control over the way the text is displayed. So instead of using the text out function, we can also use the .text function for this is also API function for covering for controlling over the way the text is displayed. You can explore this function on your own. So instead of using the text out, you can also use the draw text function. So this is the explanation of this one. This is the explanation of this program, that is what is the program. So in simple terms, I have to again going into this program. So first of all, this is a simple program that shows how to print the text, how to print the message with different fonts with different style. That is the hello Windows message. So first of all, the header files will be used, and there are two functions that is called that is the void on paint and void on destroy function. Then win main function, that is the window main function. Then there is a this is the definition of the Windows main function using the while loop, using the dispatch function, get message function. Then there is a L result function that is used for showing the result, that is the L result callback. There is a window procedure, that is the window procedure is the first function. This is the L result, that means how to display the message, that is a result the function. Then there is a callback. There is the switch case function. This is the switch case that is using. There are different cases. There is a case of the destroy. There is a case of the printing, that is the paint. There is a case of the default. Then there is a return 0. These are the definitions of the on destroy, on paint. Now after declaring or after defining these functions, the next part is using the for loop. So this is the next part, that is using the for loop. There are three parts that is using, that means it is available for the three iterations, that is for 0, 1 and 2. There are different functions that is using, that is strcpy, height, italic. There are different fonts. These are the various arguments. There are different variables that is going to store different variables. These are the text color, that is either in RGB, that is red, green, blue. Then there is a text out, that is for displaying the text. Then select object and the delete object. So these are the content that is available or that iterate for the three times, that is 0, 1 and 2. Then there is the end paint, that means ending the paint, that means finished with the printing purpose. After execution this one, this will be displayed. First of all, there is a hello Windows in Arial font. This is the hello Windows in Times New Roman. This is the hello Windows in Comic Sans MS. Also this is in a small font, little bit large font and little bit more large font. So these are the three parts that is displayed with the text, that is the hello Windows, hello Windows, hello Windows. Then this is the explanation of this one, that is how we are using the WM paint function. These are the various scenarios, various conditions in which we are using the WM paint functions. Either we are using the windows for the first time, or either it is maximize, minimize, some portion is overlapped with each other. Then this is the explanation of the switch case function. This is the explanation of this one, that is how we are using the WM paint function, what is the usage of on paint function, begin paint function. Then this is the explanation of the looping part, that is the for loop, how to display the hello Windows in three different fonts. This is the explanation of this one. This is the select object, select text color, RGB, that also uses the 32-bit color value from 0 to 255. And then this is the explanation of the delete object, end paint, that means ending of the program. Then this is the explanation of the last part, that is in place of text out function we can also use the draw text function, API function. What is the API function? That is application programming interface. The next part is drawing shapes, that I am covering in the next class. So right now let's take a break, then moves to the after break moves to the next part, that is the practical part, that is showing some programs of the C programming, that is while loop, how to use the for loop. So first of all, let's take a break, then moves to the practical approach. And this topic, that is drawing shapes, I am covering in the next class. And after doing the practical approach, I am covering each and every doubt of Larry. I know your doubts, but after taking practical approach, that is 1 or 2 programs, I am taking your doubts. Okay, so let's take a break. Now let's start with the session. So come back from the break. Let's start with the practical approach. That is doing the practical approach of the C programming. So let's move to the practical approach of the Turbo C. Today I'm going to cover your next new part, that is your new part, that is simply using the for loop. That is how to use the for loop, what is the advantage of using the for loop, and what is the syntax that is using the for loop. So let's start with the program. First of all, there is a header file that is included, that is a hash include stdi.h. Then there is a next header file, that is a hash include conio.h. Then there is a void main function, that is a main function that I am using. Then there is an indentation. Then using the for loop, for example, I am using one for loop for printing purpose. So for simply prints the values using the for loop. So I have declared one variable, that is a int I. So I is a variable that is of integer type. And then there is a CLR SCR for clearing the screen. Then using the for loop for printing purpose, that is for I equals to 1. For example, I have to print for the 5 times. So I equals to not 1, yeah, 1. Then there is a semicolon. This means this is the first part, that is a initialization. Then I is less than equals to 5, because I have to print for the 5 times. Then equals to 5. Then there is a I plus plus. That means every time it is incremented. And then this is using, that is a curly braces using for this one. And then printf simply I. Using the printf simply I have to print, that is the value of I is, at every time it will be printed percentage %d. Then there is a variable, that is a I variable. Then there is, if I want the space, I would have to give the space, and I've in the next line, then it is moved to the, then there is a curly braces, then there is a get ch function, that is user. If I compile this code, there is success. If I execute this code, the value of I is 1, then 2, then 3, then 4, then 5. So it is printed in each and every line. First of all, there is a value of I, that is at the first iteration this is 1, second iteration this is 2, third iteration this is 3, then 4, then 5. So I'm repeating this program. These are the various header files that is using. One is hash include stdi.h, that is a standard input output file. One is conio.h, that is a common input output file. Then there is a void main, that is a main entry gate, that is of return type void, that means null return type. Then there is a int main, that is a variable is declared, that is of integer type, that is a I. Then uses a for loop. This is only for clearing the screen. Now let's see, if I not use this clear screen, right, and if I compile and execute this code again, that means without clearing the screen it is printed after the value of I is 5. If I again compile this, execute this code, again it will be printed. That means screen is not cleared every time. If I am using this one, the screen is cleared every time. If I execute again, this will be cleared every time. That means clear screen is used for simply clearing the screen. Then there is a for loop. This is the initialization part. That is, I have initialized the variable. Variable with the 1. That means I equals to 1. This is a condition. That means it will execute for the 5 times. For 1, 2, 3, 4, 5. This is the condition. That means it will execute till I is 5, because it is equals to, till I is less than or equals to 5. That means it starts with the 1, this comes with the, or this goes to the 5. That means 1, 2, 3, 4, 5. Then there is a I plus plus. This is known as increment. If it is I minus minus, that is a decrement. If it is a I plus plus, this is a increment. So it starts with 0. This is the initialization. There is a semicolon. Then there is a condition. Then there is a semicolon. Then there is a increment. So initialization, condition, increment or decrement. Then there is a curly braces for defining the for loop. This is a printf for simply printing the or prints the output. Then simply uses the slash n for displaying in the each and every output in the next line. Then simply prints value of I is. That means this will be printed each and every time, and there is the percentage d. Why I'm using percentage d? Because I'm using the I, int, because I is of integer type. That's why I use d. So every time it will be using. So at the first iteration, this is 1, condition is true. Why true? Because 1 is less than equals to 5. Then simply prints the value of I as a 1. So this will print value of I is 1. Then this goes over here. Again it moves to this one. This I becomes 2. Why it becomes 2? Because it is incremented at every iteration. I becomes 2. Again check the condition. 2 is less than equals to 5. Condition is true. Moves to this one. 2 will be printed. Then again move to this one. I is 3. 3 is less than equals to 5. 3 is smaller than 5. Condition is true. 3 will be printed. In the same way 4 will be printed. In the same way 5 will be printed. Here check the condition for 5. 5 is less than equals to 5. There is a equality sign. That means 5 is equals to 5. So here the 5 will be printed. Again moves to this one. Now the I becomes 6. 6 is less than equals to 5. Condition is not true because 6 is more than 5, not less than 5. So here the 6 will not print. This loop will terminate and the 5 values will printed. That means 1, 2, 3, 4, 5. So this is the usage of the for loop. That is how it is executing the for loop. This program is clear to Larry? Okay. Instead of using d, if I am using I, then it is using like this one. Now if I execute this code, again the same output will be printed. So instead of d, I am using the I. So for integer, either we can use I, either we can use d. Alright? Okay. Now if I have to give the comments over here, so that is simply give the comments in the first line. Write a program, that is WAP, to print the 5 values from 1 to 5 using for loop. This is in comment. This will not impact on the compiler. And this is the header file. So I have to give the comment. These are the header files. If I compile this code, there is no error. Again here I have to use this one, that is a header file. Right, then this is a main function. So here I have to write main function. Here it is the variable that is declared. So here I have to write declaring the variable. So this is also in comment, declaring the variables, because it is only one variable, or either we can use this one. Here I have to give for clearing the screen. This means this is only for the user friendliness, but this is very important for the large programs. Here I have to use for loop yeah, use for loop for printing. Then this is used for printing. So in simple terms, as it is used for not for printing. This is used for the printing, and this I have to use for printing. Then this is used for showing the output. So here I have to write use for then there is a curly brace, that means ending of the loop. So this is the way how we are using the comments. By using the double slash, then use the comment. If my comment is of multiple lines, that means it is of more than one line, then I have to use slash star. This means the every part is a comment, but I have to give over here, that means star and this one. That means this is a multi-line comment. That means there are more lines. But if I have not use this one, that means the whole below part is a comment. So this is the two ways. If there is a more than one line comment, how this will be used by using the asterisk slash, and if it is a single line comment, it is simply using the double slash for this one. So this is the way how we are using, or how we are using the comment for giving the user friendliness to the program. Right. Now, if I change this program, if I change this value to the 5, and if I change this value to the 1, and if I change this value to the minus minus, right? That means it starts with the maximum value, it goes to the minimum value. It starts with the 5 and it ends with the 5. So it starts with the 5, that means first of all the 5 will be printed, then 4, then 3, then 2, then 1. That means it starts with the 5 and ends with the 1. That means first of all that is a increment, now this is a decrement. So one is increment, one is decrement. Now if I first of all compile this code, there is a success. If I execute this code, there is no output. Now let's see what is the error. If I compile this code, there is no output. Why there is no output? Get CHSA. I have to use I++ again. This is 5, this is 1. This will give the output. But if I change to 5, okay, I have to change the sign. This is less than sign and this is greater than sign. I have to change the sign over here. Now if I compile this code, the value of I is 5, then 4, then 3, then 2, then 1. So these are the 5 values that is printed of the I. That means first of all there is a value of the 5, then 4, then 3, then 2, then 1. So this means this is the maximum value, this is the minimum value. That means it starts with the 5, it goes till 1. First of all it is 5, then it becomes 4 by decrementing, that is I plus I minus minus, then 3, then 2, then 1. That means every time it is decremented to the one value, decremented by the one value by using the I minus minus. So first of all it is 5, then 4, then 3, then 2, then 1. Then simply displays the output. Now this program is clear to you, Larry? Okay. Now if I have to print only simply a line, that means I'm not using the this one. First of all, I have to save this one so that if I do the changes, that will not impact my file. This is the for loop. Now if I change to this one, if I simply used I, now let's see what is the output. There is an error. Why there are two errors? This says it cannot convert the into the character. Then this is the next line error. This is not used as a correct input. So if I'm using the int, that is an integer value, so I have to give the percentage d over here. This is the mandatory condition. Without giving the percentage d, my program is not executing. So if I compile this code, this will print in the sequence, that is 5 4 3 2 1. Why? Because we have not given in the /n, and if I give /n, it will be printed in the few lines, multiple lines, not few lines, multiple lines. That means in the first line there is a 5, then there is a 4, then there is a 3, then there is a 2, then there is a 1. That means it starts with the 5, ending with the 1. That is 5 4 3 2 1. So this is the way how we can change the program as per my requirement, as per the user requirement. So this is just a program that shows what is the usage of this one, what is the usage of for loop, right? Now if I have to give the value over here, I equals to 5. Now let's see what is the content. The same. That means if I have to declare the value, I have to declare. Now if I delete this one, now let's see. This will also print. Why? Because we have initialized the value of I in the first part. That is I simply, or I is using the value as a 5. Right. If I use this value as a 3, now what is the output? That is simply 3 times 3 2 1. That means it's not mandatory to give the value in the for loop. We have to give the value, or we should give the value in the outer part, that is when we declare the variable along with the data type, that is using this one. Now if I change this value to the float, now let's see. If I compile this code, this will print 0 0 0 0 0. Why 0? Because it is of integer type, float type, and I have used d. Now if I use %f, that means this is a float type, and this gives the decimal part as a 0 0 0, that is 5.000, then 4.0000, 3.00, 2.00, and 1.00. So these are the various parts that shows how we can display the output in the float, that is 5 4 3 2 1. Now these programs are clear to you, Larry? Hello? Okay. Now let's stop over here only, and now let's take your doubts. What is your doubts? Now let's take. You said I have a question on bits operation. When I entered the example program on the module, there was an error on show bits. I don't know I'm to hash include any file, or I need help so as to execute the exam. Thanks. Also, sir, I have not been able to download the VC++. Can you download it for the use that supports API function that we learn? Thanks. Download it and forward to us the one that supports the learning. Okay. So Larry, your doubt is the on the bits operation. That is, you are using the bits. That means the bitwise operator and the relational operators you are using. Hello? Yeah, yeah, sure. Which type? What's your error? Show bits is your error. Okay. Uh, have you included the hash include math.h header file? No, no, I will write like this one. This is the math.h. This is the header file that you have to attach in this. You have to include each and every header file like stdi.h, conio.h, process.h and the math.h. I will write all the header files. One is hash include stdio.h, one is hash include conio.h, one is hash include process.h, one is hash include math.h. All right. Hello. Yeah, all right. No, no, no. If you are using this one, so that includes showBit function includes in math.h. So there is no error around this. Okay. So in the next class, I'm going to start with the next topic, that is the drawing shapes. All right. So thanks a lot. Yes. Hello. Yes. Yeah, yeah, sure. Okay. So give me only one day. Okay, okay. So give me only one day. I will download and then either mail to you, either doing the WhatsApp, anything. So give me only one day so that I will download this from the filehypo.com. Okay, just wait for only one day. I will try and then in the tomorrow's class I will explain to you. Okay, thanks a lot, Larry. Bye bye.